Going here in just a bit. I really want to use hardware decoding or hardware encoding, but it just never cooperates with me. Luckily, I remembered to start a little early. Start a little early, make sure it's going. Hello, Fede2. Hello, DCD. Hopefully I don't get too hot here. How's everyone doing? Ooh. Good afternoon. It's been, what, 2 weeks? Last week I took off. Foamy guy filled in for me. Hi, Beata. Oh, I'm behind the thing. Get my chapstick out. There's supposed to be video here, but it doesn't like me. Hi, Timon. Cold spell is approaching. I'm okay with that. It's hot in here. Hi, Eric. I had the window open all day, even with the door cracked most of the day, and it didn't cool down as much as I would have liked. So I ran the AC for like 20 minutes, so we'll see. We'll see how long I stay cool. Now the lights are on. I got 2 lights now. Yeah. Jeff is here. Welcome, Jeff. In LA, I'm in Seattle. Does your computer heat up the room? I think so. If I get wet socks on the way here, I put them on my computer above the fan, and it dries my socks and my shoes out. All right, like right away. There's also Jod. I don't know how to say it. Sorry. WJODF in not Discord, in YouTube. Welcome as well. It's been hotter here than LA. Oof. You can send the cold weather back up here. I'm ready for it. All right, we're past time, so let's do the thing. Hi, JL. And David's also in Southern California. All right. Hello, everyone. A couple new folks, so that's awesome. If you don't know, my name is Scott. I go by tannewt online, and I work for Adafruit on CircuitPython. If you don't know, Adafruit is an open source hardware and software company based out in New York City. I work remotely for them and kind of have since I started working with them, based in Seattle here. And then my specialty is doing the software side of things, so I work on CircuitPython, which is an easy-to-use version of Python designed for tiny computers called microcontrollers. Just looking to see on my desk what I've got here, but here is a feather that is board by Adafruit. Let me switch to product showcase mode. So this is the back of an Adafruit feather. This has got a screen on the front, and it's an expressive microcontroller. So this is a self-contained computer with a CPU and RAM and storage and all of that, all in this little device. Tens of dollars to get started programming. So CircuitPython is designed to make it easy and quick to get programming computers of lots of small computers. I was going to say all shapes and sizes, but that's not strictly true. Software guy since 1985, C, C++, JVM, and now some MicroPython. Awesome. Welcome to Python on microcontroller land. What I cover here in Deep Dives, the deal is I work on the C core of CircuitPython, and we've been doing a lot of tangential MicroPython work because we've been merging newer versions of MicroPython into CircuitPython. So this deep dive tends to be just a venue where I kind of talk about what I've been working on. And then I love to answer questions and go on tangents and stuff like that. So if folks have questions, please let me know, and I'm happy to try and answer them. I make no promises about my ability to answer them. Christopher says, my Halloween feathers came in today just in time for Halloween. Spooky eyes. Awesome. I'm glad they're back in stock. Well, Jeff and David are in LA, or around LA. Okay, so I guess we'll start where I was working on earlier. So let's switch to the desktop before I forget. So I'm currently waiting for this build to finish. It looks like it's going well, which is good. The docs build was failing. So let me take a couple steps back. I was looking at issues for CircuitPython 9.0, which is our next major release. And we're about to do our first alpha release because we've merged in MicroPython 1.20. The reason we were waiting for that is because the MPY files that we ship and share around, the version format of those changed between CircuitPython 8 and what will be CircuitPython 9. But we needed to do originally 2 updates, but now 3 updates of MicroPython, 1.19, 1.20, and 1.21. And the MicroPython version underneath it all changed between 1.19 and 1.20. So we couldn't do any alpha releases calling 9.0 until we got 1.20 merged in. But now that we've got it merged in, we can start doing some alpha releases because 1.21 I think is not too far off. We'll see. Dan's been working on the 1.21 merge, but we could do releases before 1.21 is merged in because the MPY format didn't change with MicroPython 1.21. We'll see if we end up doing that. I don't know. We'll see how the tests go here in a bit. But Dan's mainly been working on that. But what I was doing is also going back through all of the 9.0 issues and trying to spot the ones that I wanted to do really early. So all of the API breaking sorts of changes I wanted to do pretty early so that from the very get-go with alpha releases, people would be able to find issues and fix them. So I snagged a couple. This one is a work in progress. Revamp supervisor allocation API. Oh, you know what? We need to do an 8.2 merge as well. We could do that on the stream. So Dan released 8.2.7, which is a bug fix release, and it has bug fixes that aren't in main, which is where 9.0 is. So one thing we could do is we could actually do that merge from 8.2.7 back into main as well. I was just thinking about, I think I have a third issue here assigned to myself. That is, this matrix portal S3 hard fault, which I fixed in 8.2, but I did not fix in main. And so even though it's flagged as 8.2x, it's still open because issues get automatically closed only once you merge into the main. David Buchanan asks, is there an advantage to changing the MPY files? I don't actually know why the format's changed. I know one thing that the MicroPython folks were trying to evolve towards, and I don't think they've finished, is the ability of being able to run MPY code without copying it into RAM. So there was, without copying it into RAM, so running it from Flash, but it had to be in Flash linearly. So they were talking about having like a custom storage system to be able to store linear MPY files in Flash. I don't know the state of that work, but I think some of the MPY changes were done for that. The advantage for us to change the format is just that we stay with the format of MicroPython. Even though they're not cross-compatible, we actually do change, there's some, the first character of the file is an M or something, and we change it to a C, just so that our MPY files don't inadvertently get used with their stuff. There's there's not a lot of differences. Like we haven't gone out of our way to actually change the MPY format at all. So I don't know of any advantages. I don't know what the differences are. All I know is that like in the process of adopting upstream MicroPython changes, we're going to evolve. And one thing I've kind of set out for us is that like we will only do those MPY version changes on major version boundaries. We teach people to get the like major version bundle of MPYs, even if the version doesn't change. So like 6 to 7 or 7 to 8 at least, like the MPY version didn't actually change. But we wanted to kind of like just teach everybody the process of matching major version for the times that it does, like with CircuitPython 9. Yeah, so the only advantage is like keeping up with them. Oh, nice. So Jeff posts their first board. You designed it? I can't read it in my small. It's got terminal headers for every pin. It's pretty neat. Okay, so we're gonna soon get into the world where we're releasing alphas, and I want to do all the breaking changes as early as I can, so we have as much time. Hi, Paul. I think you're the reporter of this bug that I picked out that I might take a look at when we get there, after I recap. So yeah, so this one's fixed. We could do the A2 merge. The revamp supervisor allocation API is going to come after 121. And then I'm revamping it by removing it, mostly. But this split displayio is a thing that had come up. And it allows you, the idea being that like if you have a board design that has a display, but doesn't really have connectivity for any other displays, you should be able to like pare down what code you're using so that you only have the support for the thing that you actually need. And I kind of like saw this and I thought about it and I thought, you know, like this is going to become more true as we do like more fancier displays like dot clocks. So we should just go a little bit further and like split some more stuff out. So that's what this this branch is doing. I have split displayio, and let's look at the commit history. It's a little bit circuitous, I guess. It's got more than just the split in it. So the split is just so here's what we're renaming. Display becomes bus display. Bus display dot bus display. 4-wire is 4-wire dot 4-wire. E-paper display becomes e-paper display dot e-paper display, and I squared C display becomes I squared C display bus and I squared C display bus. And then for a little bit more clarity, parallel display is now parallel display bus. And all of these are still available under their old name. So we kind of like point the old names to the new version of the object so that like code should be compatible for 9.0. So the old versions of like displayio.display, that'll go away in 10. But the new version busDisplay.busDisplay is available in 9. So that's what this is trying to do, is like lay that foundation. We tend to try to have one overlap major release. So for example, another major change in 9 is that we're deleting display.show. Like we're removing it in favor of .rootgroup. And we've had some issues with that. But yeah, so this is like that earlier step of like making sure we have a major version where two things are available. So it's a lot of just moving stuff around and renaming. Timon asks, how do you deal with deprecation like that? Does it log a warning if the old name is used? We don't. Oh, it's an Adafruit breakout board. We don't log it, and generally what happens is we don't go back and fix things until we're in the next major version. So like right now we have a lot of work to do to change all of our example code from show to root group. But we know that when we do that, all of the existing 8.0 stuff will still work, right? So it's not that we're going to warn you about it. It's that you're like, everybody should be using the version that supports the new way of doing it. And you know, the folks on the leading edge using the 9.0 and the 9.0 alphas are the ones that are finding the places that it just doesn't work anymore. So yeah, it's kind of a like, this new stuff is going to be there in 9.0 so that new code can use it if they know better. And like the documentation is up to date, but the old way will still work. And then when we do 10, then we'll remove it and we'll find all the places that we haven't updated yet. Thanks for purchasing from Adafruit, Jeff. I appreciate getting paid by Adafruit. They're great. I love this gig. So thank you for supporting Adafruit at adafruit.com if you don't know. If you're on the YouTube and you're not in the Discord, you can go to adafru.it/discord to get in there. See, I didn't even know that we had that terminal breakout block. That's Adafruit 5096. 96, I think is what it is. Huh, I did not know that. Oh, it's from czhlabs.com. Okay, so it's purchased from Adafruit. It's not designed by Adafruit. Huh, I hadn't seen that. Huh. Neat. Okay, so I was doing this displayio split, and I was doing some testing. I actually did like some smoke testing. Makes sense. So more convenience for core users and less for staying compatible with wild old code. Yeah, all the old code will be fine. It's more for the folks that want to update. We tend to support two versions of CircuitPython, major versions of CircuitPython at any one time, right? And we do that as we transition from one version to another. So we usually have like the stable release, which is 8.2.7 now, and then we'll have CircuitPython 9 alphas. And then we'll have this process that we just went through with 7 and 8, where like at some point we'll decide that 8 has been out long enough and we've found the bugs and it's stable enough that we can stop supporting the previous version. So 7, like before we started changing libraries and example code for 9, we stopped building the bundle for 7. So there's a page, I forget where it is, where you can download a bundle that's like the last bundle that is theoretically valid for a particular major version. So like, where is it? I think it's in CircuitPython Essentials. Maybe, no. Maybe it's the Welcome to CircuitPython guide. It has a FAQ, I think is where it is. Yeah, so I had to continue using CircuitPython 7x or earlier. Where can I find compatible libraries? So we have links to these old zips that are like the last kind of version. Jeff asks, so Python does not have deprecated annotations like JVM languages. I think Python itself does, but I don't run across it where I'm using it, and I haven't, you know, as somebody who works on an alternative version of Python, like nobody's come to me and said like I need to be able to mark things deprecated. It would be good to be able to note it in the docs, and maybe that's something that we should look at too. But I'm kind of in the camp of like, for 9.0, if you look at the docs, you'll only learn the new way. Like I'm kind of okay as I'm okay not documenting the old way. Like you can always look at old versions of the docs themselves. So yeah, in the docs I kind of just want to leave it the new way. Okay, so that's one thing. But when I was testing it, I found that rootgroup didn't work. So and I was a little worried. So we're trying to do this transition from calling a function called show, where you give it the group of the stuff that you want to show on the screen, to having an attribute that is root group, or it's a property under the hood. I don't know if CircuitPython has a way to do warnings. I don't think so. It hasn't come up. But yeah, so we're doing this transition from root group property, from a show function to a root group property, and it has a couple nice property or like benefits of doing root group. One, you can read back what's showing, so you can see what something is actually showing. And two, and this is different behavior between show. If you set it to none, if you set root group equals none, nothing shows on the screen. Whereas with show, if you passed a none, it would show the terminal. So now with root group, you actually have the ability of turning off the screen. And if you want to show the terminal, we now also make the terminal available to you so that you could assign it back as the root group if you wanted to. So yeah, root group's the future, but it does this thing that it has a property in a native class, and it turned out that when I was testing it, I found that no longer worked. And this is a deviation we have from MicroPython. And so what happened is that during the merge of the newer versions of MicroPython, we like omitted the code that made this sort of thing work. So the next thing I did in this branch is I fixed it. And the way that I fix it, it requires you to add this flag. But the main interesting bit is that I added a test now, where there's a Unix port, so a version of MicroPython that you can run on Linux or Mac. And so I added this NativeBaseClass to it, and so now we can see that like it's also testing the ability to pass keyword args in. So it prints out what .test is, it sets it directly, prints it out again. Now it subclasses that NativeBaseClass, sets it through the keyword args again, prints it out, sets it through the property, prints it out. And the misfunction with the way that it works kind of currently in main is that when you do this a.test, it'll create a new attribute on A. It won't actually tell the native class that it was set, so it doesn't actually affect it. So what I was seeing is that like it was assigning this new group to the root group, but it was still showing the terminal. Is the kind of like consequence of it. And then here's a second variant of that where it overrides in it just to make sure that stuff works. And then there's this exp that like prints out what the test should actually produce. So yeah, that's one test that was missing. So when we do a merge, we want everything to build, we want everything to kind of work to run, and then we also we want all of the Unix tests to pass. We want all of the builds to run, and we want all of the builds to build, and we test kind of at least one board of every port to make sure that like all the ports work okay. I'm going to turn on the AC. I know it's a little loud, but it's 81.1 in here and just getting hotter. It was like 80. It's gone up a degree. So I know it's going to be a little loud, but it'll increase my streaming stamina. So you have it cooler in here. Yeah, so this was a case where I changed the behavior in the py file. So I added a note in obj property, and then this is in the class lookup. It says, oh, if it's a property, then we just return the property itself. And then also, as you subclass, you inherit this special accessor flag from your base types. And then I also added a check. So this is new. So the problem with native types is that there's no automated setting of that flag. You have to manually set it. So how do you know if you set it correctly? Well, I added this thing that says if properties are enabled. This is a particular like accessor method, and it says that like, oh, if you got a property, just check to see if the type has that flag, and if it doesn't, it sets the result back to null, basically saying like, I didn't find it. I didn't find it. So now with native classes that don't have the flag set, the properties won't work. You'll have to set the flag, otherwise it won't. Jeff asks another question, and totally like beginner questions are totally fine. I'm not always the best person to answer them, but folks in the chat can be helpful as well. I know this is deep dive, but can I use the Python plugin in IntelliJ with CircuitPython or VS Code? Again, I know this is a deep dive, but not beginner. So personally, I don't use an IDE, so to speak. I know there's a VS Code CircuitPython plugin, but I don't know how well it works. I know one thing that happens is that you need the stubs. So we publish a CircuitPython-stubs that will stub out all of the native stuff, all of the native classes. And that tends to make fancier IDEs happier. But yeah, I don't have a lot of experience with it, so sorry. I think there is some, like a learn guide about PyCharm, which is like by the IntelliJ folks. I don't know where it is. Creating and editing code. I mean, mu is what we recommend, but the reason we recommend mu is largely just to get people like doing the. I use Sublime Text, and then I have a separate terminal that connects to the serial output. Is usually how I do it. But then again, I'm mostly doing C. I don't do a ton of Python actually. Okay. Oh, there's a recommended editors page. Oh, it's under advanced. Yeah, so there's a little more information there. Recommended editors. Oh, and Timon found the PyCharm and CircuitPython, which is probably under advanced here too. Yep. But yeah, so my workflow is that I use Sublime Text to edit the files, and then I have a terminal window with TO open. And TO is great because it auto reconnects, which is awesome. But yeah, that's usually my setup for how I do it. Of course, I've never really worked in a world where I had a really strong IDE. I still do a lot of printf debugging as well. Okay, so the last thing that I ran across in this, so I found that rootgroup didn't work, so I fixed that. And then you'll notice that this build is broken. And the reason it's broken is the docs build failed. See this docs build. And if we go there, yeah, I like Sublime Text a lot. I use Sublime Merge as well. So the PDF build, with this splitting displayio, the PDF build started failing. And there was a couple reasons for it. It doesn't look like, oh, it did load. It loads this giant thing. It spews a lot of warnings. So the raw file works better. Like there's all these hyper reference warnings that it spews. If we go to the bottom, there's also this badness thing. Blah, blah, blah. But the actual failure here is that it like ran out of main memory size. So I think we were on the cusp of like being too large, basically. And I looked for an easy way to increase it, and it's surprisingly difficult. So the thing that I ended up doing instead, and I was doing this most of today, is that I'm splitting So not only do we build HTML docs, but we actually do build PDFs as well. So here is the new version of the PDF, and maybe I should open the old version as well. So if you're on docs.circuitpython.org, you can click in here and then hit PDF, and it will, so these are the 826 docs. Someone says, Sublime Text was my editor for a really long time, but made the switch to VS Code last year because the remote development tools they added were a huge time saver for Raspberry Pi work. So this is what the PDF currently looks like. It's got kind of one top level thing and then stuff nested under it. And it looks a lot like the README. And the thing that, well, core modules and then the module support matrix. So it's this that really takes a lot of pages. Like if we click between here, we're on page 8 here, and then if we click to supported ports, like the next section, we're at page 314. So the support matrix, if you don't know, is really cool, but it's not really designed for, so the equivalent here is this module support matrix. And this is really cool. So this is a list of all the boards and all of the modules available on a board. And if you want to say like, okay, what has Pico DVI? You can type it in here and it filters it down to all of the boards that support Pico DVI, which is really handy, but it also generates like 300 pages of PDF, which is wild. Ooh, I want to see that. I'm going to copy this link too. I'm so used to never leaving the IDE. Yeah, see, I've never really worked in a space where I could actually do that. Yeah, so going back to the docs for a second. So it's kind of deeply nested, not well organized. So in my switch here, I actually added this docs PDF to RST, which is like the top level file for doing the include. So I could just restructure everything. So let's look at the new version. I don't know. Let's show the sidebar. I wanted to always show the sidebar. This is a different viewer, so it's a little bit different. But now we have CircuitPython, we have the libraries, library bundle, building, blah, blah, blah. So a lot of top level stuff. And then we have the API reference. And this is where all of the like individual things are documented. And then what I did is if we look in, this is in CircuitPython build LaTeX. So if you build it from the root, there's now a second PDF that you can open. Is just that table matrix. Now it doesn't link back, which is kind of annoying. And it's a little weird in that it's like portrait, but I figured out at least how to make it, it's a weird landscape. Like I thought it would switch everything, but it only, yeah. Anyway, it's landscape. And so that's here instead. So this is I want to be able to look up for a given board what can I do. So it'll be in a separate PDF, which means that we'll be under that memory limit again. Yeah, it's LaTeX, and it's so Sphinx builds all of our. We have Markdown and RST, and then that gets the RST gets run through Jinja, and then that Jinja gets produces more RST that gets converted into HTML and LaTeX. So yeah, so that's the other change that I made to fix this build. So I was working on that. I was thinking a little bit about like what order would I want these things to occur in. Chapter 3. That's a whole chapter. It's not perfect. I'd love for folks to tweak this some more, but I can't spend too much time. But I was thinking about like, I have this vision of CircuitPython kind of filling that 80s 8-bit computer gap. And one thing that those always came with is like reference manuals. So getting this at least a little better is like, you know, it's okay, it's 366 pages. Like maybe I could start to think about printing it out. So yeah, thinking about this as like the reference manual you'd print out and flip through if you were in some world where you couldn't just look it up online. So that was fun, and that's what I spent most of today doing, is just getting the deprications. Okay, let's take a look at this Pico Vision. I was waiting for it to come out. I'm curious. So it's a Pico on one side. And then a board with another RP2040. RAM A and RAM B. GPU debug, CPU debug. So I guess they're calling this the GPU, yeah. Interesting. So it's RP2040 plus Pico W. Line audio DAC HDMI port. It's interesting they're calling it HDMI because I wonder whether their board design is so good. Sort of bank switching / frame buffering. The hardware Atari 800 manual. Pandoc. Have I seen the flower badge we made for CC Camp 23? I think I did. I think Carl, who's in my hardware happy hour, brought one. Saw that it was like an ESP running MicroPython, I think. So I wonder how they say you can use it. What resolution does it support? So it says C++ or MicroPython. If you're a beginner, we recommend MicroPython. Higher resolution modes use significant GPU overclocking. C++ MicroPython libraries. Add a USB keyboard. How it works, here we go. Uses two RP2040s, swapping the contents of two physical PSRAM frame buffers back and forth between them. The two PSRAMs act as a front and back buffer. The CPU writes to one while the GPU reads from the other. Applies some hardware effects and generates the DV signals. Yeah, so here. This is not stock MicroPython. It is Pico Vision Python, MicroPython. Pimoroni has their own fork of MicroPython, and people need to understand that. wonder what all the modes are. So we have Pico DVI support, which allows you to output DVI signals from a single RP2040. I think I did get it to 800. Maybe it's doubled 800 by 600. Yeah. Hardware overview. Good docs. Okay, so here's the widescreen build. Yeah, so there was rumor about this that they would be able to do 1080p, and this is not doing 1080p, and that's fine. But it is higher res than what we can do, I think. Most of what we can do is pixel doubled. And we don't have this like double buffer sort of thing either. And they do allow sprites. 80 sprites is a lot. I mean, this is still really neat. We'll see what people think. See how well it does. I think it probably has too much. I don't know how they're talking about it, but there's GPU firmware. Differences from Pico graphics. Not displayio. A whole RP2040 dedicated to display tasks only, yeah. So Jeff says, let's see. Flower-shaped touch synth with a round display. But a lot of stuff running behind the scenes on IDF. Yeah, get that stuff checked in. Although synth.io has been really quite cool. I don't know of a CircuitPython version for this Pico Vision, to be clear. I haven't seen anything come in, and I don't think I'm not gonna do it either. Jeff says, so CircuitPython does not have hardware interrupts, but you can drive a display. A lot to learn. So we don't expose hardware interrupts to Python land, but we do use hardware interrupts under the hood. So if you need hardware interrupts, you can do it. You just have to write C code, not Python code. Maybe you have a plan to do iSpy to DVI. What would be the resolution? So iSpy, is that the new, I forget what, is that, that's, yeah. iSpy breakout connector. This is for the SPY displays, right? Lots of SPY pins. Yeah, so there is like an Arduino example already that pretends to be like a SPY display and then outputs to DVI. I think there's an Arduino example that already does that, but I don't think we have a board for it yet. So our stuff is based on Pico DVI, and we could just see what the resolutions for that are here. And I'm sure this is what they're building on as well. They don't just tell you the resolutions, huh? There's a software README. But this is, they explain how they do all the like encoding and stuff. Software README. Don't get the bad apple thing. Yeah, there's like different modes. I forget. Do we have it in our docs? Oh, you know what? I don't know if Pico DVI is in here. I think it was a... Oh, no, there it is. Pico DVI. 2 output resolutions are currently supported, 640 by 480 and 800 by 480. If it's monochrome, either 2-color or 4-color, it'll be full resolution. Otherwise, it'll be half resolution for more colors. Thanks, Jeff. Have a good one. MPEG video playback too, which is a fun feature. Gotta upstream that stuff. I'll have to take a look. Python payload. Ooh, did you do MP3 decoding on ESP? Yeah, we'll have to take a look at this. LWIP. Why do you include LWIP when you're doing, fetch data maybe? MP3 draw. Yeah, we'll have to take a look at that. We don't have MP3 decoding on ESP yet, I don't think. That would be cool. All right, I stashed that in my other browser for later. Okay, I feel like, so there's a couple things we could do. There's one bug that is Paul's bug that he filed. Is one we could work on, but I also bugged Dan and he pushed the 121 merge. You know, in fact, what I want to do is I want to make a pull request. Since this displayio stuff looks good. I waited too long. If I push it immediately, I can do that. So my guess is that this is going to work. Now, this is annoying. I forked my version of CircuitPython based on MicroPython, so it always defaults to the wrong thing. But if I do Adafruit main, now I get the right thing. Okay. I want to crib this. This is the comment. Broken by a preview. PDF doc build now fails due to the size of the support matrix. It is split out into its own main PDF now has a dedicated root file box. Okay. All right, so I'm going to create this pull request. Jeff's on vacation, so I'll request Dan to do it. And we might want to wait till 121's merged in, because I touched a lot of files. And then, you know, the other thing I want to do is I want to do the 82x. The 82x thing as well. So let's go to here. Let's git fetch Adafruit. Okay, so now I want to git switch merge in 827. So I should be on, oh, I'm on split. That's not what I want. Git reset hard, different main. Okay, so I'm on main. I'm on a branch called merge in 827. Before I do anything else, I'm going to git status, and it doesn't look too bad. So I'm going to do git merge 8.2.7, and we're going to have to fix some stuff. But I want to get that, in particular, that matrix portal fix. I want to get in here. So I'm going to do that. Please manually handle the merge of each conflicting submodule. Go to the submodule and either merge the commit or update to an existing commit, which has merged those changes. So I don't want to change any submodules. So I'm gonna go make fetch all submodules to try to get back to the main state, I think. I should have titled this Scott Does Git. Mm-hmm. It has dropped down a little bit in temperature, so it's nicer in here. Okay, so it updated the ESP IDF. We should just double check that. Ah, yeah, we don't do GPL. CTX dependency. Hi, Gary. Thanks for dropping by. Okay, before we get going, I just want to see what ports Espressif ESP IDF is on. It's on 5.1, so that's what we want. Git add ports Espressif ESP IDF. Getting her done. Yes. And Unexpected Maker, who hasn't shown up yet, sometimes shows up, didn't want me to update his boards, but I think I'm gonna have to. So let's, we still have some merge conflicts, so I'm gonna pull up my trusty Sublime merge as my first place I can go here. So no I2S on CMG 51. But turning off floppy IO and GIF IO is probably what we want as well. So let's just do, so I have a really hard time knowing what the left-hand side and the right-hand side are. So I tend to just pull up like the files on GitHub as well. Boards, ITC, M4. And I can already see that. Yeah, so floppy IO, GIF IO, and then if we switched 8.2x, we'll see that the I2S thing went away, but I think that, yeah, it's turned off by default now, so it's going to be removed from a bunch of boards. So I think what the right thing is to take here, but then you can also delete stuff. So I think this is what we want. we want the two things that were added from the left-hand side, but not the thing that was removed. And then here, it looks like a spacing change. So we're going to take the left-hand side and the right-hand side. But what we're really going to do is... did somebody ping you? I'm doing the 8.2x merge, so I think I'm going to have to update the board defs you added to 8.2. So I think that's right. Save and stage. So this is the same thing where something's being turned off to save space. So we'll do the left-hand side, but then delete the audio bus bit, because that's now going to be shared. And this is why wanted to watch it again. I didn't mean to shame you. PR 2 new boards to 8.2x. You just missed 8.2.7 with that, but we can always do an 8.2.8 for you as well. Okay, so looks like this. So the left-hand side is main, and the right-hand side. So this is 42 and 21. Oh, you know what? This is a change I did. So we sold a few of the Metro S3s and then pretty quickly realized we had a problem. So if you were one of the people that bought a Metro S3, the Rev 1, I thought I was shaming you by saying that you hadn't like popped in the stream yet. I'm happy you're here. So if you got a Rev A of the Metro S3, we'll send you a Rev B when we have them. Because we had to change the pinout in order for something to work. I'm going to assume the left-hand side is correct. Dnit singleton. Ooh, this was stuff that I fixed. Oh yeah, there's this new all complex resolved. MDNS server. I might want that one after all. Oh, Dan's watching. Dan, I'm sorry, I haven't done your... I got distracted doing the A2 merge. I was gonna try to run the tests and see, but I haven't gotten that far yet. Okay, so I merged everything in, I think. And I don't know what the... Oh, here's the new boards. These are the things that I've got to update. So there's the Magic Click S3, and the Unexpected Maker Blizzard. So let's get over to this, and we'll build those two. Make board equals Magic Click. So I'm going to have to update these for the new style, I think. This is needed too. I know, but I bugged you about it. I forgot. But yeah, I want to get the fixes from 827 in the main. Was that the Rev A pictured here? Yes. Really slim down SDK config, so I can imagine that's the major change. Yeah, and in fact, I can show updating the board config. That's what I can do. I'm assuming it's not going to build. Let's take a look at what we're dealing with. I had a few files open. I want ports. I was working, oh, that's what I should do. So I'm helping Scilabs with a tech talk next Thursday morning. If you want to attend, it's really early West Coast time. It's 7 a.m. West Coast time. But I have in my email a sign-up link if you're interested. Let me find it. I'm sharing. I'm just doing part of the presentation, and then the other folks are doing, like somebody from Scilabs who did the implementation is going to do it as well. So I will copy the Tech Talk details there. I'm going to be talking about CircuitPython generically, and then they'll talk about the implementation on the Scilabs chips. They do not have native USB. They have BLE instead. And they don't actually have the BLE workflow on, so they just suggest doing Thani. Put my hidden window down here. Okay, where did my text go? I assume the Tech Talk is free. My main concern is I gotta get up really early. Like I'm gonna do it from here at 7, and I have to be there earlier to check like my mic and my video. Yeah, it's gonna be kind of early. That's okay. It would be way worse if I didn't have a 1-year-old who got me up early anyway. Okay, we're looking in boards. Boards. And then we're gonna do the magic. Click. Let's look at the SDK config. Yeah, so this has a bunch of SpyRAM stuff. And the thing that I was looking at is it's in quad mode. And it's 2 megabytes. Yeah, I think it's bytes. So we'll do CircuitPy, and then we now have, instead of flash, we have PSRAM, and PSRAM. So I just inherit the settings here. So quad 2 megabyte. So we do QIO 2 meg, and the speed is 80, so that's right. So I'm going to add that. Is there not a registration link? Let me open the link. I don't have to register, but not message link. Copy link. Let's see what it's got. That's the link. I pulled it from an email. Yeah, so here's a register pane. I'm in Firefox, so I assume that's what you do. So yeah, check that out if they're interested. It's very, very cool because Scilabs is like, you know, somebody at Scilabs actually has made all the changes and stuff to CircuitPython to get it working. And in their docs, they say, like, this is the official, they say, here's the official CircuitPython. They link to circuitpython.org/downloads. So that's really cool. I was testing it with the latest 120 merge, and I found some bugs, and I had to fix it. Turns out we had broken it in 9, but it should be fixed. Fixed in 9, and I also, there's a PR for this that got merged in already. They hadn't set the pins for status LED, so I added status LED pins to the 3 boards that they support, which I have all 3 here, so I did test them all. And I added a note and made it easier to flash and stuff too. And this is there was a watchdog timer problem. Okay, pop the stack. Undefined reference. So this is probably the build error because I didn't set those things. So let's, what I want to do is I'm going to do a clean, now that I set those things, and now I'm going to do a menu config, which might work. I thought that should work. I'm going to rebuild it, and then I'll do menu config. Yeah, it's cool. It's cool to see vendors supporting it. To their credit, Sony is the first vendor that did it, like the Presence. The Sony's Presence, that's also done by somebody at Sony, which is cool. So we're happy to have that stuff there. We do occasionally just like smoke test those things, but they're not kind of our bread and butter Adafruit supported stuff. But we're happy to have them in. Happy to have them in the repo and to do the reviews and merges and releases and stuff that they need. Okay, so I'm going to rebuild it, and then I'm going to run menu config. And the menu config, what it should do is it should update the SDK config and really reduce it down. Like all of these settings, all these SpyRAM settings should go away. The only thing left should be this local hostname bit. I think we could do that by running the menu config commands, because the menu config. Actually, I added a second command. What is the second command I added? I also added makefile update SDK, board SDK config. So once that's done, I can do that. Do. And then we'll want to do this for unexpected makers board as well. Oh, it didn't fit. It's an S3 with a little flash, so for those I've been disabling BLE.io. Because BLE.io is really not that interesting / useful. But let's do update board SDK config. So this is debug output, and it's telling you for things that are not default values, where they're going, except it's not telling you where they're going. I must have removed that. Okay, so let's go back and look at SDK config. So now all it's got is these two things, and I just don't want those, so I'm going to delete them. It's trying to preserve them. So I'm going to clean again and update. while we're at it, while we're waiting for this one, let's do the unexpected maker one as well. The Blizzard. So it's 8 megs quad PS RAM. I tend to like to put the size first. Unexpected maker, this flash mode can be switched in main so that you probably want it quad. When it's actually flashing it via the command line, it'll automatically take quad and do dual, because the boot ROM doesn't do quad. Oh, flash is 8. Okay, perfect. SpyRAM. This says SpyRAM size 8. $880. Is this wrong? You might want to fix it in 8.2 then. But yeah, that's kind of why I did this change, is makes it a lot simpler. Okay, so now we're gonna do unexpected maker. Sorry, I just moved the window so I could see it. Board hardware changed 2 days ago. Okay, so it's just not been updated. All right, I'll make it two in this one. So I'm gonna build it. It's gonna preserve some settings. Stock. This is stock. I fix that. This I don't need to change at all. Wait, is this your Fpga board? Ice 40 Spy Bridge. Ooh. Microcontroller plus an Fpga. I gotta find some time to work on that. The Pico Ice looks interesting too. I really I'd love to define my own sock. I did, so the Scilabs chip is a Cortex M33, and I did notice that it hard faulted when I was, the watchdog problem was that I think that was the watchdog wasn't clocked. The clock hadn't been enabled to it, and when CircuitPython tried to access it, it was hard faulting, which is better than stalling. So I'm hopeful that the M30, the new generation of ARM cores are actually better to program on. Okay, so I think it's only these two. If we go back to the other tab, there's another Raspberry Pi board, but those I don't think they need to be updated. I don't think it needs to be updated. These ones automatically merged. I think it's only the RGB matrix fix we do want, and it merged just fine. It's only the Espresso boards. We got it switched for 5.0. Hi, Ask Patrick W. Is there a Mastodon link? I'm really trying not to go to Twitter anymore. In my opinion, everybody should be off Twitter. I don't want to open the Twitter link. Twitter has been removed from my phone. The day it became an X, I was like, I can't do this. Mastodon's quite nice. I'm on Mastodon. Okay, let's go back to the other tab. It built okay, but we want to update board SDK config just to delete. So with the main, the update to IDF5, I made our SDK configs not include non-default values. Whereas some of that's almost entirely true. Yeah, so this is just it's trying to preserve these incorrect settings. Oh, and the light turned off. This room has a motion sensor overhead light. I know there's some people on Twitter still, but I can't do it. I just don't. I don't like Elon Musk. I do agree that. Ooh. Oh, you know what? I think I might have seen this anyway, or maybe it was in the newsletter. I know, I still do have my account, but Mastodon is where I'm at. Of course, I don't post a lot either. I think this was in the... Okay. I can't hear the video. I think I can make it so the stream can hear the video too. Turn on desktop audio.
Hey everyone, because I've got nothing better to do with my time, here's my Blizzard S3.
Okay.
The DVIP mod.
Ooh.
Rotating cubes. Just added some basic 3D functionality to the graphics library, as well as n-gons, so n number polygons.
Neat.
What was that?
Okay, so you're using the ICE40 to output DVI. What resolution are you getting out of that? That looks neat. Hopefully folks could hear Sion's explanation. Yeah, I totally agree that I'd like a bit of an algorithm for Mastodon, especially because I see like some people that retweet a lot, but I like the actual posts more, even though I don't post myself that much. Okay, so I deleted that stuff. Now I'm gonna clean and I'm gonna do it again. Just to make sure. Yep. So it reformatted. Now we only have the LWIP host name. I was wondering if audio could be heard. Great. Thanks, Patrick. Okay, so this is up to date, and it's so up to date, it's even got the right RAM for the other thing. Yeah, I'm in Mastodon camp. I love that it's a nonprofit and you can support them on Patreon, and they publish everything. So that's 320 by 240 at 256 colors using internal SRAM, but now I have PSRAM for the frame buffer, so you can do 640 by 480 16-bit and maybe 720 with 256 colors. All graphics code in CircuitPython. Do you have the ability to just like hook into displayio and just have it work? I don't know. I have the displayio bias. I know other people don't like it as much. One thing though that is neat is that I think by doing this split that I kind of showed before, I'm actually segmenting out like the hardware side of, the displays a bit more from the displayio tile grid group thing. So I think there is a world where we actually like have some ability to do one but not the other and that sort of thing, which people would be happy about. Okay, this is done. This is done. I love deleting code. This is done, and this is done as well. All right, so we're up to date. And we're going to finish the merge by doing git commit. And there's a formatting problem. Some more places where we need a space. So we'll stage that. Go back and do it. We looked at adding displayio, but it was a lot of work and stuff I didn't understand. But the plan was to add that at some stage, or the community can add it. So I guess you're storing a frame buffer on the ICE40. So maybe you want, yeah, you could probably do an adapter. I don't know what the protocol is that you talk between the micro and the Fpga, but you could make like a, it's very much like a bus display, where displayio would tell you like, oh, write these new pixels here. But yeah, that's neat. I'd love to get more into FPGA stuff. It's an up 5K, I assume? ICE40 UP 5K? Writes the ICE40 frame buffer just via SPI. Does it do, is it like normal SPI displays? Like, is it the same protocol? You could just tell it it's a ST whatever. And have it like just use 4-wire to the FPGA. Blue Sky is public benefit, a B Corp. Huh. 8 megabytes of PS RAM. That's neat. All right. Let's push it and we'll PR it. Yeah, I have a Mastodon account on one of the servers that's run by the Mastodon people. Yeah, I don't know public B Corp versus nonprofit, but I do like products that are from B Corps, like the cheese, like Tillamook Creamery makes cheese and they're B Corp, I think too. I don't think it's a legal designation. But, okay, let's make another PR. Let's overload Dan with reviews. This one should be easy though. He does all these, most of these merges into 827. Oh, come on. I wonder if we'll have to make another tag. This might merge in the tag as well. Pushing pixel data via SPI at the moment. Yeah. Be a bridge between AT and the activity flow down the line. Ask Patrick Maker, ask Unexpected Maker, how do you decide to make a new board? Do you have specific use cases in mind, or is it just about combining hardware in ways and seeing what people make with it? I know the Adafruit answer. Adafruit answer is definitely specific use cases. Like, what learn guides would you write for a given product? Although there is a class of Adafruit products are like, I want to make a bigger board. Like, breakout boards are usually made if a component's going to be used in some bigger board later. Okay. So that is out for review as well. So we've got half an hour. The other thing I was going to do, and I was bugging Dan about, was to try and help fix some tests. So I'm going to fetch dhalbert. So this is a great example of Gitness, because I have more than just like one remote. So now I'm getting the latest changes of Dan's copy of CircuitPython. So he has this v121 merge. So we're going to do git switch v120 packet type 21 merge. And now we're switched and we're set up to do track Dan's branch. And I'm going to do the make fetch all submodules, which I think is going to fail. But we'll see. So when I was doing that root group fix for displayio, I got more comfortable running the Unix tests and figuring them out. Unexpected Maker's answer is, I try to make products that I find interesting, that usually solve something I either dislike in other options or that I can't find elsewhere. Okay, just updating all of our submodules. If you don't do this, you risk accidentally adding like the wrong version back. Avery Angle was cool, thanks Scott. Of course, I don't actually design a lot of products. That's my observation with how Lemore works. Blizzard S3 was specifically to see if I can solve that FPGAs are intimidating to microcontroller users. Yeah. That is definitely a world I've thought about a lot. I have lots of ideas in the FPGA space that I want to do. The two main ones are like, in the same way that I kind of like just started the ULP support, where you can have a Python ULP library that automatically brings its binary with it. I'd love to be able to have FPGA-based libraries that bring the bit stream with it and load it automatically. So you just like import a Python library and it would load and do all the FPGA stuff under the hood. I think that'd be really cool. Then I have a lot like other ideas about how to like define this stuff that actually goes on the FPGA as well. But it's a lot of work, a lot of understanding. There's people definitely moving the FPGA world and hardware world the way that I want it, but they're not to the point that I would like to be. Okay, so let's do ports Unix, and we'll do. Dan told me that he got the coverage variant going, and I'm just gonna clean to make sure that I've got everything. So let's run the tests and see where we're at. Dan's just done an initial merge, and he just got the coverage variant building, so fully expect that there's gonna be some issues here. That's how it goes. Don't ask why. Custom tinyUF2 that allows people to drag bit streams on the drive for the ICE40, plus you can also just drag them into your CircuitPython drive too and have it just work. Neat. I know that the Pico Ice folks have that custom tinyUF2 as well. The Pico Ice is a RP2040 plus an ICE40 up 5K, which are becoming more available now. Okay, we've got work to do. So 21 tests failed. What I'm going to do is there's this results directory. I'm going to just remove that and run it again. Dinner bell. Enjoy dinner, retired wizard. Thanks for hanging out. I'll probably have a snack after my stream. Yeah, easy programming without tons of tool change is definitely the hard part and the problem missing piece. Yeah, I really would like to get, like, I always push FPGA people to like distribute their stuff pre-built, and they just like their eyes their eyes glaze over and they're like, why would you want to do that? Don't you want to customize it? Therefore, I'm just like, no, like, yeah. Amaranth is the thing that gets closest. Oh, I see. So Pico Ice says you have to convert the bitstream to UF2 for it to work. We don't. Just drag it on and it works. You drag a bin file onto your bootloader and it loads it? Or it makes sense to me on CircuitPy because like you have more, like you're writing into a file system in the interim, but that's not true with things. Okay, so some of these look pretty familiar. Some of these look like things I've fixed in the past. The extra coverage one is usually pretty normal. So what I'm going to do is I'm going to go in the results here. And I'm just going to look at what yeah, so we have this like leading 0x. How did we faked the fakeness of tiny UF2. We faked the fakeness. So you're actually writing the file to, so your bootloader is actually writing to a flash file system now. Yeah, White Quark does a lot of good work, but I still have an idea of I want to push it one more notch into Python land. Like I read a lot of Python drivers in CircuitPython from the outside in, and I want it to look the same from the outside. Like I just want it to be the driver. I sketched it out. I did this but it's not well documented like a lot of my stuff. Like I have this system on a chip project that I did 3 years ago. And I was like, what I found myself doing is I'm in the IRC channels. I tried to explain it. But just because I try to explain it doesn't mean I managed to. But a lot of what I was doing is like reversing the way things are connected. So like starting from the outside and passing things in. So like here you can see like random access memory is taking in like a range from a memory decoder. And then I'm like documenting it like a regular variable. And then timer takes like a bus object into it itself. Yeah, we probably talked about it. I haven't done anything since then. The thing that is kind of in this vein that I've started to work, that I did a little more work on was what I realized is that you could have a lot of the same functionality for cheaper if you just ignore the desire to be an FPGA. And this is the STM32G0 on a Stemma QT board thing that I was thinking about, where you would have a CircuitPython library. It's kind of like Seesaw, where you have a CircuitPython library, you tell it here's my I2C device that you're going to talk to, it's this address, and then it loads code onto it, and then you interface with that code. And it turns out it's a lot cheaper. It's a lot cheaper than an FPGA, and the STM32G0 is neat because it has an I2C bootloader. So imagine that you load code that does an I2C target, and then it has a special or consistent register or number that if you do that, it puts it back in the bootloader mode. So it's kind of like the ULP stuff as well, but yeah, it just never got there. It's in contrast to Seesaw, where Seesaw is one firmware that tries to do everything. The G0 stuff was designed of like, well, what if you just have like particular firmware blobs that it loads on for certain things. But yeah, this is the thread I would pull if I ever had time to work on FPGAs, which is a good way to put it. Okay, we're back to fixing tests. So, oh, this is what I did. So to see a diff, I can do copy test results Unix coverage to the expected one. And now if I look at my diffs, we can see everything that's changed, and we can say, like, is that right? So in CircuitPython, we have the 0x prefix, which I think is more correct. And then this is just like a redoing of the listing. So that looks right. And if we rerun, now that we updated our expected output, we should get 20 failed tests instead of 21. So let's do the same thing for, well, let's look at the Unicode one, because we do have more advanced Unicode. Last I looked. Expected versus output. It's not at the top of the file. Oh, see, we have updated, yeah, let's just copy the Unicode one too. It's Unicode. So I think this is right. Unicode out. And copy to unicode.py. Oh. So this is a case where, okay. So if there's no .exp file, what it's doing is it's showing you what CPython does. And that's what we would want to match as well. So this is a case where Unicode, what is this? The expected version has it commented out, and the actual version doesn't. So we can do build coverage MicroPython tests unicode.py. We'll run it, and we see that we're not commenting it out, even though CPython will. So we want to fix that. And those are like on the boundary. So we have, like, Unicode has this complicated notion of what's printable and what's not, and we approximate it in CircuitPython. And we try to do a better job of approximating it than MicroPython does. Let's just take a look at, but we're not perfect. We're not perfect is what the remainder of that thought. So let's see what the tests Unicode does. And you can see there's a fix Unicode test thing here. Test invalid. Print repr. So the other thing we can do is we can look at Dan's tree. Tests. Hopefully you didn't fix this already, Dan, if you're still watching. Blame. Yeah, so here we have printing of Unicode characters using repr. Oh, that's with repr specifically. Okay, let's dig into this. We have some changes around here. And they were done so that we would print smiley faces. Like I changed them so we'd print smiley faces. If we look here, we can see that there's a... Oh, look at that. Huh. In 2021, I fixed this test by changing what it prints. Is that what we want? Yeah, so this is what I was thinking. And the change that I'm referring to, string Unicode. These settings approximate CPython's printability. CPython document in here. If it's between this range and this range, then we escape it. Other ways that we print the full character out. Yeah. So I think the thing here is just to reapply that commit. So I wonder if we could just fix Unicode tests. If we just copy this commit and just reapply it, git cherry pick. Ugh, so much garbage white space. There we go. So it'll have a new commit. Yeah, see, it was FA684. So it's basically redoing that same work. That's what like cherry pick and rebase do. It's just kind of a convenient way that I've done it once that way already. Yeah, I don't know when FPGA land. Once in a while, Lamore's like, maybe I should do FPGAs. I think it was partly like, oh, I could get chips. 19 tests. All right. I fixed 2 tests. Ideally, we'd be able to fix like more than one test at a time. Yeah, we're almost out of time. Results. Let's just take a gander. Out. No module name skip if. Awaitable is not iterable. Awaitable object is not iterable. We added the aNext stuff. I wonder if that's a flag issue. Skip if. Yeah, so a lot of these look like the skip if thing. How do we fix that? This comes up every time, I think. Yeah. I'm the one that added skip if, and I can't remember how it works. Here's a JSON thing. But I have a feeling like we fixed the skip if thing before. I know. Tiny test code gen. Test for import skipif and inject it into the test as needed. Like, whoa, we have a rosie.yaml file still? I added that like my first year when I was trying to, yeah, 2017 and 2018. Like, this is when I was trying to do automated onboard testings. When the test results say crash, what actually happens? Good question. So let's try it. It's usually that the build actually like segfaults. Well, returns non-zero is probably correct. So here, but then there was it can either be a segfault or just an exception, I think. No module name skip if. Code. Test lib. I don't remember this. Like, if we just look in test basics 2 years ago, tests, history, fixed tests that use skipif 3 weeks ago. So we want to bet that this is not in there. Tests, run tests, 715. Yeah. Oh. It has... has E, but it looks like the end of E was dropped. Output expected. Let's try it again. So onboard testing rosie.yaml was not a success. Yeah, the rosie stuff was just not reliable. It got, like, the boards got into states where I would have to like manually reset them so that we could load new builds. And then the other problem was I was using a Raspberry Pi, and the churn on the USB stack would actually expose bugs in the Linux USB stack, which is not great. So like the Raspberry Pi itself would have to be restarted. Huh. That didn't fix it. Did I not? Yeah, I look forward to the day when reliable onboard embedded testing can be done. Beata, what do you think is cool? Annoying but cool? Okay, so let's see what the results are now. No module name skipif. That's the change, right? E, Python path, lang, check output, env E. It's to check output. Oh, accidentally hammering something hard enough to expose bugs. Yeah. I hung UDev like this week. Like, I could see the kernel was seeing USB devices, but like dev serial blah 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 wasn't being updated correctly anymore. Like, I think if I had to do it again, what I would do is, one, I'd use CircuitPython as a host, as the USB host. So, pick a version of CircuitPython that works, use it as a USB host to isolate your USB stack, and two, load over SWD. So just like make sure that you can always load, you can always get it in the state that you want. Don't rely on the Rosie stuff was using like a UF2 bootloader to do it. Don't do that. Like use SWD, be able to control reset and power to the like target device. Like if I had to do it myself, that's what I would do. Okay, so end E is being passed into there now. This is to run CPython to work out expected output, but that doesn't mean that it's running MicroPython with it either. Like this is the CPython 3 command. Am I looking at the wrong? This out file is what MicroPython should be running. So how is that being done? Run MicroPython. Command line options needed. Instead of subprocess check output. Oh, this is for the REPL version. Arg test file 254. How do we do it? Arg test file subprocess standard out. So we're not giving it the environment there. Huh. What if I just run this? Where is it supposed to be? Unexpected Maker says, I'd love to find a few weeks I could just sit and focus and really start to learn FPGA stuff. I find it's not something I can just learn in a bit of time, especially when I'm constantly in MCU land jumping between CircuitPython, MicroPython, and C++. Yeah, me too. The problem is I have a lot of opinions how I'd like to do it because a lot of there's a ton of smart people in the FPGA world, but they're all at the like super low level. Like, how do I do clock domain crossing and things like that? Whereas like, I'm like, I want to use Python to assemble a SoC. I want to take this CPU and put this RAM and this SPI controller and this, like all this high level stuff. And I want like good docs on all of those high level things. And there's tools like Fuse SoC, but it's not Python, and it is a build system for all this stuff, but like all of the docs get built when you do that. Because I think I'd really like, I'd love to just run CircuitPython on a soft sock, and the orange crab with the ECP5 is like a great piece of hardware to do that on. Like it's a feather form factor ECP5 that could have a soft system on a chip. They've done a lot of work there. It's just like, I really want pre-built stuff too. Like, give me an ECP5 image that I can load and give me a PDF of the docs, right? Like, I was even thinking it would be cool. Like, what if you could construct a soft sock but had like like where you could plug in peripherals? So like, it's not doing full place and route, but it's doing like on CircuitPython, maybe you could like patch it together. Would be really cool. The commercial tools offer that, but then you pay $15K to get the DSI feature. Yeah, I get it. Wait, what is this second test live here? At 10:23. Maybe that's what we're missing. 10:23. Oh, here we go. MicroPython. Let's check that. Heyo. That's not what we want. Soft feather wings. No, a soft feather. Soft feather wings would be cool too, but different. The challenge with putting an FPGA on a feather wing is that, like, generally you want pins out of it, whereas like all the pins that go out of a feather into feather wings. Let's see, CircuitPy change. Add test live for skip if async stuff. Cost and availability of IP blocks, definitely another big thing missing from accessible FPGAs. Like, there's a lot of those libraries, but there's no consistent, like, this is what FuseSock is trying to fix, I think, is like having a package manager for standard IP blocks. But like, I want to see documentation for an IP block before I integrate it, right? Like, I want like the equivalent of like read the docs for a particular library before I get all the build system set up. And I also want to be able to like not have to build it myself. Okay, let's run the tests and we'll call it after this. CircuitPy would be of limited use if I had to write my own GPIO peripheral to do anything. 100%. And we actually have the LightX port, right? So it was designed to use like the peripherals from the LightX ecosystem. But like I said, like when I pitched this idea of like you need to have pre-built binary, like pre-built systems to load onto an FPGA, so I don't have to I don't have to install the FPGA tool chains. They're like, FPGA people's mind explodes. Like, that's the whole point, right? Like, the whole point is that you install the FPGA tool chain so you can change it. And like, oh, how do you load software on that? Well, you run the thing. Oh, I broke more tests. 40 tests failed. Looks like I broke async. I broke more async tests. Well, let's take a look. No module skip if still. Let's just do it. Delete it. Run it again. I think sometimes you can have stale output here. It still said no module. Not iterable, but also no module named that. There must have been a change. Run tests. MicroPypath. This is... Dan's copy. What branch am I on? Dot frozen. Gordy says, sorry, I meant apps that you could plug into the FPGA feather instead of plugging a hard feather wing into the outside of the FPGA feather. Yeah, like apps that you could load into the feather itself. Yeah, that'd be cool. I think I get what you mean. It's kind of like the same idea with the STM32G0 stemma. It's like you can just load whatever you want there. Unexpected Maker says, fixed compile gateware for one-off functions is okay. Something I'll be doing for the Blizzard S3, like here's the DVI stuff. But how to do I want DVI out, NeoPixel, and I2C, and SPY1. If you want them at the same time, then it's hard. But if you want to be able to switch to them, you should be able to just like ship different CircuitPython libraries that bring the gateware with them. If you want the gateware to do something, then you need like a management thing. Like the fixed stuff, I would always assume that I have like a CPU core and peripherals that I can turn on and off. And, like I just want to treat it like an MCU, but one that ideally in the world where I could like make it work better for what I'm using it for would be really cool. Okay, so it is MicroPypath still, and we're joining by the OS path separator. There is no empty. What is this? How does this change it? Unix main. Oh. So it's like overriding it? That's weird. This is a weird change. It's explicitly adding frozen. But leaving empty. So I think this is an example of something they inherited from us, this dot frozen thing. But I wonder... I wonder if we have these changes. Oh, I just want to fix it. Ports, Unix main, 500. Fixing a lot of this stuff is like, okay, what? Like, basically, what do we have? Path num. path starts as, and that's what? Path items 0. Where's the syspath stuff at all? Set the base directory of the script as the first entry in syspath. So this is just like different. You know what we can do here? We can print this stuff out. Actually, you know what? We can just run it. Let's get a copy of it. OS environ MicroPypath. Let's do repr so we get quotes, and then we'll just sys exit. I don't actually want to run the tests. Okay. So this is what we've got. So now let's try to do env. Hey, look, it's in my history. Build coverage. MicroPython. Tests. Basics. Array. Intig. Okay, let me catch up on this Fpga description. Get blame doesn't have many clues. Yeah, the tool chains are quite unwieldy. Yeah, the open source toolchain folks are awesome. That's why ECP5 is the way to go. You got to get it set up on GitHub Actions so you can auto build it. The format of environment changed. So I think what changed in 121 is that they added the dot frozen thing like we did. Expert in gateway design, but you have to kind of get the interesting peripherals. I was taking the approach of like taking existing Amaranth peripherals and tweaking them so they're wrapping correctly. Like that was my problem, is that like Amaranth doesn't use Python abstractions to map to FPGA like peripheral abstractions. It's more from the like Amaranth is just the builder and definer, but it doesn't actually like abstract stuff away. And that's what I was trying to figure out. Yeah. I'd love to work on this, but it's just like they're so expensive, and Yeah, the interesting peripherals don't exist as open source. So, well, yeah, but part of the problem is that a lot of the high-speed stuff is not actually done in Fabric, right? Like, it's proprietary hard IP for a particular thing. But what does exist, from what my understanding is, like, at the end of the day, you're still generating Verilog, and it's just like some Verilog instantiation that you're connecting to. Okay, so this doesn't work. Let's see. Import sys and print sys.path. Okay. You know what? We're not in testlib. Or like we're not in the place that testlib lives. So let's be here. And now we've got to do ports Unix. I thought that was right. Oh, I don't want to go back 2. I want to go back 1. Import sys. Print sys.path. Import skip if. See, it worked there. So it works there. Can I also run basics? Which one was it? Array int big. It worked that way. Let's, what we can do is we can modify the test. Sorry, I know I'm over time, but I'm in the middle of this. And it's cool enough in here. It's cool enough in here that I'm like, I'm okay going a little bit more. So what we can do here is we can modify the array int big test to also do import sys print sys.path. And now if we go back to ports Unix, make it. Oh, and I modified it. So let's undo that. Am I editing off screen? You know I do. Sorry. So I added import sys and sys.path. Ice Storm or Ice Studio? 40 tests failed. Now we pull up the results. That one test should fail because we're outputting something different now. Home, tannewt, repos, CircuitPython, test baskets. Oh, are we in tests basics? Whereas test lib is relative. So I wonder if we do run tests base path. Let's try that. And maybe to be more like, I think it's okay if we do frozen first. Let's try this. Okay, so that one array one will fail still because we're, dang it. It still failed. Test basics and then test lib. It doesn't have a slash. it doesn't need a slash. That is so weird. I thought that would have fixed it. Does your debug print trigger compare errors? Yes, it does. Oh, but the skip if works now. Okay. But we still failed most of those. And I only put it here. It has a C Python crash, which is not good. Python tests. Oh, so it's having the same problem. That was in that other location. Maybe it's moving directories now? What is this base path thing? Base path. Fail, fail, fail. 26. And it's mostly async stuff, which is not surprising. Not surprising. There's like two different async IOs. Like we have our copy and they have their copy. And maybe it's that awaitable is not iteratable. Task queue object has no attribute pushhead. That I know how to fix. This is something I fixed in the 120 merge. Or, yeah, I think I did. Sorry, this is what I think of as test-driven development, which is, it's broken and I must fix it, and I will keep on working and working and working until it does. Shared bindings. Where is event queue? Or task queue? Oh, that's in. Where is task queue? Oh dear. It's in xmod. This is something they removed and we have to add back. And I thought we marked it, but we didn't. Task queue, push pop remove. Yeah. All right, let's fix this too. Last thing. We're not gonna fix them all, but test-driven OCD, yeah, for real. It's an xmod. It was marked and it still got vanished away. Come on, async IO. The file was renamed. Push head. Oh. We need them because the old names are in CircuitPython 8, and we need our library to work with 8 and 9. Like that. Okay. Let's see how many things we can fix with that. Last thing, then I'm done. Thank you all for hanging out with me. This has been a wonderful time diving deep. I'm Scott. I go by tannewt on Discord and GitHub and lots of places. If you want to go join the Discord, you can go to adafru.it/discord to check it out. If you want to support me, just support Adafruit. They pay me to do all this work, the streaming, the hacking, all that stuff. Adafruit.com, buy some cool things there. Thanks to Unexpected Maker as well for being awesome open source. Hey, we're down to 7. Done 7 tests. Okay. Yeah, do that. If you want to do the Scilabs thing, check the chat histories for links to the Scilabs Tech Talk. It's Thursday morning next week. I'll be up bright and early. Hopefully I'll remember. I will remember. It's been great hanging out with you. I'm excited about the FPGA stuff, even though I could never find time to do it. Maybe I will at some point. And keep an eye out. Keep testing CircuitPython 9, and we'll get there. It's going to be exciting. It's exciting to be up to date with MicroPython, or at least almost so. So with that, have a great weekend, everyone. I'll get these changes pushed, and Dan can help fix these other ones as well. Thanks to Dan for doing a lot of them.